Alrighty. How's everybody doing today? Making sure it's all up and running. Okay. So today, I've got a bunch of stuff that, it's been a while since I've just tested all the things. Kind of gone through and ensured that it all worked. The other big change that I want to highlight here, I've rebuilt the the electric network, the way that it works. Now, this doesn't affect, or it won't affect players. They'll update the mod, load their game, and they won't see any difference. But behind the scenes, I've massively changed how everything works. Okay. And hello, the Oz and Elisa. So yeah, I've redone it to basically it uses a new system, right? Before, just to give you a quick rundown before of how it worked. When items were added or removed from the network, like when you wire something up and something was added and blah 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 blah, right? Or when you initialize, when you load it into the world, it would load all of the nodes that are in the network, and then it would parse each one of those nodes, and then it would add a copy of the block entity into separate lists, right? And so then I had a completely separate list of entities that I had to manage, and those entities, right? This is where bugs creep into code. Is when you have a snarled mess of objects and stuff that you have to track and maintain. So the separate list, I had a separate list for producers and consumers, for storage entities, and even relays for some reason. And what would happen is, you would wire a machine up to the network. That event of wiring up to the network would get captured, which that's still how that works. So that wire event gets captured. It determines it is a power wire. It is something we need to pay attention to. We need to look at that block entity, and we can look at the block entity and say, oh, this is a machine. This is a consumer. Add a copy of the entity, right? Or it's basically a reference to a separate list. And then my electric network was parsing those lists, right? And saying, oh, here's all the producer nodes, here's all the consumer nodes, here's all the storage, right? And up until now, 3 years of this mod, it has been relatively good, right? Mostly stable. There have been a few scattered reports of issues, but those are usually edge cases or somebody's in the middle of doing something and the game crashes for another reason, and some data is scrambled. So I've been wanting for a while to sort of revisit the power system, and I finally did that, and I surprisingly was able to pop it out pretty fast. I thought it was going to take me a few more weeks to do this, but it actually took me just about a day, just about a full day of coding. So now the electric network here, we have 3 different delegates. And a delegate is just, how do you define a pattern, right? How do you define a pattern of a call, right? Of a function. I need to define a pattern of a function. And that's what a delegate does. This is the pattern of the function, right? It returns a ulong. It wants one ulong, a float, and a bool. And the same with this one. It's basically the same thing. But I also built it around the electric system, right? I've already got calls that apply those patterns. So extract power, receive power, and storage power. This is a new handler that I had to add into the interface. I had to add a call, storage power, that applied these variables to the parameters. So, because storage really does, as I was coding it, I originally only had these top two. I originally had those top two. But as I was coding it, I realized that I am going to need a separate, like, I need to separate the storages, because they have some unique behaviors, and I need to account for those behaviors, right? Storage is, they're the last to get excess power. They need to supply some of their power, so it's just like, storages are a very, very special, unique case. But what I did then is I added events that use those handlers, right? So these event is basically like, imagine it's like a click event, right? On mouse down, or on interact, or some other event that is happening behind the scenes when you do something with a computer. There's an on key down. There's other, like, events rule your machine. This is how the machine works. So I have 3 different events here: on extract power, on receive power, and on storage power. And those, again, are expecting this pattern of functions, this pattern of parameters, sorry. So if I want to add something to this event, I need it to have this pattern of parameters, which my electric block entities already do, right? On receive power and extract power are this pattern, right? And so I have these now for each electric network. Again, the electric network itself has these events. So what happens now, instead of me adding references to block entities that God only knows what happens if they unload out of memory and all that kind of stuff. Now what I do is, when a node joins, right? When you add a node to a network, what it does is we still have the all nodes. That is still important. I still have a reference, or a list of all of the nodes in this network. That is a very important thing. But what I don't have is 4 other lists of all the things, right? I don't have 4 other lists. What I do is I detect what kind of entity it is. Again, this is just edited code from what it looked like. And rather than add the entity into another list, I use those events and I just do a plus equals, and I give it the entity's receive power or extract power or the new storage power. I just add that function call of that behavior into the list, right? And this is a unique call. This is a call to that specific machine, that specific behavior, and that specific call. That's what I'm adding here, right? It's not a generic call that's just called everywhere. It is that specific machine's version of that call. And I do a minus equals before I do a plus equals. And the only reason I do that is I want to ensure there's only ever one copy of this call in the list. There's no other way, really, there's no other easy way to ensure that I'm not double adding, like, receive power, right? Because if I add 2 copies of the function to the list, this is essentially a list, right? This is a list of pointers. That's basically what it is. It's a list of pointers. And I could add more than one of these into that list. and that machine would get called twice in the tick, right? Which would be bad because now you're double dipping. You're either double dipping on the extraction of the power or you're double dipping on the insertion of the power when you really shouldn't be. So consumers receive power, producers extract power, and then toggles, storage, and transformers have store power, right? Storage power. They're basically batteries. Toggles are like switches, like a lever or a light switch. That's a toggle. Storage is just a battery, and a transformer is what it is. And the relays, I removed the list altogether. There's literally no reason for me to keep track of the relays. They don't do anything. And I do have extra code in here, right? If it's a pass-through, the pass-through being like one of our MV connectors, right, that sit on top of a machine, that's a pass-through. Then if it's a pass-through, then I grab the entity that is the pass-through, right? The pass-through entity is, hey, this is a pass-through. Find what actual entity that I need, and that's what this should be. And if it's null, then it writes an error to the log and it exits. It doesn't actually do anything because the entity is null. I can't check it, right? If the entity is null, then it doesn't exist, and I can't check it. So add node is the same as join, right? Join does the same call. Leave, all leave does is just remove the call, and the remove node as well. So I should, yeah, there it is. So I remove the node, and then I remove the actual call. So that removes it from the simulation. And then the update tick here, this has been massively cleaned up. Like, holy moly, has this, like, here's a block of code that I was able to clear. All of this is not needed. None of this is needed. Right? This is a lot of like block entity validation, and we don't need it. Because this here is saying, hey, if all three of our events are null, which means we don't have anything added to these. We don't have anything added to these. If these are all null, and our nodes count is 0, then just remove the network. Returning false from here just removes the network. Otherwise, if all of these are null and all nodes.count is greater than 0, that means we have relays. That's a network of relays. That's all it is. Which could be a temporary network, right? It could be a network that somebody is stringing, power between, power poles and stuff. And so it's like, yeah, if all nodes.count is greater than 0, that means it's basically an all relays, which we don't need to simulate, so just return true. Because we don't need to simulate it, there's no power to move. If there was even a single battery or transformer, then this would be false. This would not pass because, a battery would be a storage power, same with a transformer. If a generator was on here, we would have extract power. So the only edge case that this covers is if it's just pure relays. That's all it is. So then we look at, then it's just the same algorithm, right? I've commented out a lot of these lines because it's, you can see like this is kind of what the call was before, and this is what it's turned into. So now instead of doing a for each through a list of block entities, which are much more substantial memory-wise, right? We're saving a huge volume of memory. The bigger the network, the more memory we're saving with this, which is one of the main reasons I wanted to do it. Because now the event, right? Now the event, all it is a list of pointers, which is basically an int, a single pointer, and it's pointing to all the different calls in memory that it needs to address, right? It's all those different objects in memory. That's what I'm pointing to here. And so we're iterating through all these delegates, and then we're just I have to cast the delegate to be able to invoke it, because this delegate here, this invocation list, is getting me a generic delegate, and so I have to cast it into whatever that delegate is, which is the extract power delegate. And then the invoke is just calling. This invoke actually calls the function that it's pointing to and passes it those parameters, right? And so I basically run the simulation just like I did before. Like this is very much in line. So you can see the code I comment out, and then the code that I have, right? So there was a couple little shenanigans that I had to figure out, but everything works. It all works, and it's phenomenal. And there's one nasty edge case. There's one nasty edge case, and that's this one here. This edge case is a lot more complex than it was before, because this edge case is if receive and extract are null, which means we don't have any generators or machines on a network, but storage power is not null, which means it's a network of batteries and transformers, basically. That's all it's on it. And this edge case is nasty because it's all storages, and what we want to do is rebalance the storages, right? We want to balance the storages out so that they it's almost like a swimming pool. Imagine you have a bunch of different tanks, and you have some that are high, some that are low, and you want them all the same level, right? You need to take water out of this one and put it into here, and so you need to rebalance the tanks, so to speak. That's what this function does, and it's kind of, it doesn't use the delegates at all to do it, because what it actually does is go through the all nodes, right? I'm processing the nodes directly because there's no way, I don't have a way with the function calls that I have now. There's no way to pull the total capacity and total power and total numbers. All of the function calls via the delegates all are based on the delta time, right? So it's like how much can we do in like, so it's hard to find again the totals that we need to calculate, because I need to know to rebalance effectively, I need to know what the total capacity is of the whole network. What is the total amount of power that we have as capacity? Then I need the total amount of power in the system, right? How much we have total capacity and we have total power, right? That gives us, again, a baseline of, aka pressure, of a %. So let's say we have 10,000 power capacity, and between 4 different objects, 4 different batteries, we have 5,000 power. Well, that's 50% a baseline. So 50% is my baseline. Well, the battery, you could have one battery that's completely full and 3 batteries that are not, right? So we want to balance that power out. And this is what does that. We grab the total amount of power, right? We grab the total amount of capacity. That gives us our target pressure, and I call it pressure because it is essentially a pressure-based system. Right, so I have a target pressure, and then I iterate through all of the nodes again, which I do here. I basically build a list of the storage nodes because they have to be storage, toggle, or transformer. I can't have relay nodes because relay nodes could be an all node, so I can't have a relay. So I grab all the storage nodes, and then I iterate through them, and I'm like, all right, well, what is the pressure of any individual node? Right? What's the pressure based on that baseline target? So if target is 50% and we're looking at one that's like 85%, well, that one is definitely in surplus, right? So I do a check here. If node pressure is greater than target pressure plus 2, what I'm doing with the plus 2 is I'm giving it a 2% buffer. Right, to try to eliminate the constant wiggling of power. I'm just basically going, all right, I want you to be within a range, but I need a dead zone. I need a dead zone in there where the power hits that dead zone, it just stops. And then I do node pressure less than target pressure, and then I have I could do a target pressure like -2 here, and that would give me a wider dead zone. But a +2 dead zone is, unless there's a problem, then I can fix it. But it usually works pretty well. And then we have the deficit nodes as another list. So we have surplus nodes now and deficit nodes. So now, if either of the nodes counts as 0, which is kind of weird, but if any of them are 0, that means we can't move any power. So we just kind of bounce. I should have a check up here. Storage nodes. We have storage nodes.add. I need to do another bounce. If storage nodes.count equals 1. Return true. Yeah. If all we have is one node, we don't need to calculate. We don't need to do any of that other math. Yeah. We don't need to do any of the other math. Right. We have one battery. We have a bunch of relays, but just one battery. That there's no reason to try to rebalance that. Anyway, that just bounces us out of having to do this block if there's just one, which would be fine because it would just run through this once anyway. Okay, so then if all of our counts are right, then we can go through and do this. And then we just grab what I try to do is I try to reduce. Let's say we have a network where one node has a crazy amount of surplus. Right? We have one node. And this is why we want to test. Because what happens if one node has a huge amount of surplus? We need to rebalance that a bit. So what this does is it says, hey, what is the power, right? We have an amount of surplus power, whatever that amount is, and we divide it by how many nodes are in deficit, right? Which is basically how much power should we give each node, right? We have surplus nodes and deficit nodes. How much power should we give each node? And then we basically give that power, right? Receive power. We give that power. I'm tracking the power left over because maybe there's a problem with my delta time. There could be myriad of things. There could be a bunch of different reasons why the batteries are not taking the full amount of power. So after I run through that, then I have how much power we didn't give, right? Power per node is the division. How much power didn't we give? Then we reduce surplus power by that because it's power we didn't use. And then we say, hey, the surplus power is divided by how many surplus nodes we have, which is, hey, this is how much power we want to take per node. And then we process all the surplus nodes with unfulfilled power, right? Which is, hey, it should pull like all the power, but then if unfulfilled power is not equal to 0, then we throw another error. So that function is the edge case of a network that is just storages, right? Transformers or batteries, which it's a lot of processing for that. So that specific kind of network is the most inefficient in this whole system. And then the rest of this is the actual network simulation, right? If you have a single machine or generator on a network, this is mostly MV networks, but if you have a single machine on there, that won't even go into this block. This won't even be run because you have a machine or a generator. So then this will be run, and this code works. It's edited and updated, but it works like a charm. So what I want to do is we want to test. We want to test a few things. So let's go in and test a few things. And hey, Los Paterno. I really should update my game too. So yeah, like I said, the new electric system, won't affect. Like, you're not gonna have to rebuild anything. You're not gonna have to redo it. It'll pick it up right where you left off. You shouldn't really see any difference. The networks work great. So an example here would be, let's clear that. Right, so we have all of these. So let's remove these two. Oh, not those. Batteries. Okay. So we have two batteries that don't have anything, and then we have one that's damn near full. So let's wire in the two, right, that don't have anything. And then if we wire this one in, this one will drain into these two, right? And so,
chat.
How is this new network manifest? The new network is more efficient, and it's way more memory efficient. Way more memory efficient.
Plus, hopefully, since you've gone, sifted through it nicely, it's got less of the edge cases.
Well, the number of edge cases doesn't really change. An edge case is an edge case, but what it allows us to remove is shenanigans involving having a dangling block entity in a list somewhere, and if that machine is unloaded, let's say you're traveling super fast across the landscape away from your base, and something happens where, you know, a chunk is unloading and your game crashes and something happens, right? Well, now we've got a network that has a dangling sort of memory address of an entity that may or may not be loaded in memory, and that could be, you know, a bad thing. And it's just one of those it's one of those like programmer black holes that you could create a crash or a memory leak, because now we have a duplicate copy of that entity, right? You have imagine a block entity, right? The block entity, the footprint in memory of this generator, right? However many bytes that is. The electric network was having basically like a pointer to that block entity, and so the garbage collector was having a hard time cleaning memory, even if it was unloaded. If the electric network didn't release that block entity pointer, the garbage collector wouldn't collect the actual entity when you left your base, which could create a situation where the garbage collector is not being as efficient as it could be. So it's just little things like that I was trying to avoid. So you can see these have balanced themselves out now. And if we hook them up to this doesn't look like it's doing anything, but these are getting power. And if we look and find one of these, there's this one. So this is actually delivering power to these. Now these are LV batteries. These are very minuscule, 100 power per second, right? So that's a total of 300 power per second. This thing is capable of putting out 1,000 power per second, which is why it's like not doing a lot. And they're an hour full. So it's all good. Now, if you really want to pull some power, this beast, this thing here is, the way that it's built, it's maxed out. All six extensions. We can grab a bucket. And put a bucket directly in here. And so now this thing is pulling 5,000 power per second. Okay? And it's crafting now a single run of the crude oil, which is 10 liters, which is what a bucket is, right? You put a bucket in there, it's 10 liters. This is a 5-minute long craft. You add 5,000 power per second. So this maxed out craft takes 1.5 million power to process. Right? But what it gives you is all of the things. Right? All of these can be burned as fuel if you wanted to. So you have diesel, you have heavy, you have lubricant, which we still have to figure out what to use with that. We have kerosene, gasoline, naphtha, and LPG, right? These are going to be eventually able to be cracked down, as well as heavy oil, to be able to be cracked down with the giant chemical plant. Because we're planning on. But I have all of these pipes going into here, and they're all using the new subnet system. I can show you that. I need a free hand here. So the subnet here is going into this subnet here. Say that again?
Got a follow-up question?
So it auto-saves our back of the network in case of a crash. The game is auto-saving it behind the scenes all the time. It has pulses of save events that occur. I don't control any of that.
I think it's in regards to the network.
So it auto saves or back of the network. The network saves whenever the game does a save pulse. The network saves. It's just included into that process. So the network will save with the game when it saves. But another thing I've done here is if we remove this and this, okay, one thing you can do is you can daisy chain oh 5. Yep. I need wire and then pop. So you can daisy chain these MV connectors. You don't have to have crazy shenanigans with the connectors. And this thing is taking pretty much the entire bit of power we have here. I think one of these is actually empty now. So I'm going to need to put some more fuel into you. How about we do gasoline? Some gas in there. And I have the portions spelled out there. You can see 569 portions just because these tanks are so big that they hold a lot of fluid. A lot of fluid. I think it's like 800 liters you can put into one of these. Which is, I think, 80,000. Yeah. I think it's 80,000 portions will fit into one of these. It's a lot. But, yeah. This one... Why? Oh, we have a problem. What happened? Oh, never mind. That's my bad. I was looking at the power per second. Which, this power per second is set at 2,000, but it's really not. It's depending on the fuel. What I should do... when I go, this is another thing we can test here. We want to do block entity, multi-block, fluid generator. And when we do find matching recipe, liquid fuel props.
More questions.
Ooh, more questions. I like questions. Right now, using a bucket doesn't deplete it. There's no way to deplete of liquid. Like little bits at a time. I would need a bucket that's 1,000 liters. Right? To take a full block. The way that the water in the game works is it's kind of intended that it's an infinite source. So two options that I could do. One, make crude oil not bucketable. Okay, that's one option, which is probably going to be the most likely option. That you won't be able to get a bucket of crude oil just because, yeah, it doesn't deplete the liquid. Because a block of liquid is 1,000 liters. Right? A bucket is 10. So 100 buckets is how much fluid is in a single block. So that you can bucket out a lot of fluid, and if you wanted to manually fill a tank up with oil, you could use a bucket and do that. But remember, the crafts for oil are based on a 10-liter input, so it's a bucket per craft. And if you wanted to spend the time bucketing oil, you can do that if you wanted. Okay, so we have liquid fuel props. We have electric.set max power per second to liquid fuel props.energy power per second. Bool add to base. False. You want a U-long. Okay, so let's hot reload that. Go back to game here. So this should add, yeah, there it is. 1,000. This is empty. So I'm standing there staring at an empty thing. This is now 1050, right? Because this has got gasoline in it. This is 1100 because it has kerosene in it. And this is, again, 1050 because it has gasoline in it. So this one here, we have diesel. We have a decent amount there. What is there? Another fuel we have over here. Lubricant is bad. Let's take some gas. So yeah, this thing now is 1050. This must be done. Yep. And now it's filling up with power. It doesn't go to 100% because I would literally void. I would waste power or fuel. It would waste fuel to go to 100%.
Another follow-up.
You tell me that if I take 100 bucket and I fill that one oil with this. No, the oil. You can take a tank. Let's grab this tank. So this tank, right? This tank can hold 256,000 liters. Right? So we can take this tank. This will hold 256 blocks of fluid. This is nothing I'm going to test today, is actually pumping this down. So you can take a bucket and go, here. Now, you're doing 10 liters at a time. Okay? There's 100 liters. That is 1/10 of a block of fluid. 1/10. 1/10 of a block of fluid in there. So, how much time would it take to go from 100 liters to 256,000? You're going to sit here a while. You're going to sit here a long, long time. Right? So, what we want to do I have another one of these tanks? I do. Okay. I'm gonna because now that I have power gen, I want to now that I have some power gen here, I want to test all of the shenanigans over here. It just sucks that this was found on a hill like this. So I want to give myself a pump. There we go. And we're We're gonna test, but we're not gonna craft all the things. Because Jesus, that would be too much. All right, we need some power. I forgot how far can we stretch these? Pretty far. Okay, so let's go to like right here. I really should remodel the MV versions. These are just bad models. They're so tiny and stuff. They need to look more substantial. They need to be. And then we're gonna go down to the lowest point. We want to find the lowest point in this. Come on now. Do this. Can I grab this? Okay. Now, crude oil. See? Pumping crude oil. 309 blocks remaining. That's a test to see if it actually can pump this whole thing out. I need to bring that wire down here somewhere. I'm probably going to need more MV wire. And this is an LV machine, so we can't hook this directly up to MV power. So we need a transformer, but it is going to consume a lot of power. So we have this going to here, and that should be getting power. Yep. And then now, this can go to here. And then we take, and we put a pump like okay, so where? Oh, I see the fluid draining. Is it coming out of here though? I'm not. Where is the? I'm not seeing the spout actually drop. It should be pulling that spout because it's based on distance. I mean, it is pulling quite a bit. I'm not 100% sure why it's not pulling the spout though. This one's 1200 power per second. We're not able to deliver that. I'm going to have to rebalance the pump. Yeah, I'm going to have to rebalance the pump. This is why I wanted to test. Why is this not coming down? Or there's this. It pulled all of this stuff, which is great. And there's a full tank. Right? Yeah. 256,000 liters of crude oil. Did I miss? Okay, so the problem here is, for some reason, it was not able to find these. So, I hate when I hurt myself like that. It's simple. So I'll put you here. Why did this miss the spout? If somehow just didn't see it, or it didn't see those either. So I wonder if that's because of distance. So what does it see here? 21. There's way more than 21 blocks in there. Like, way more than 21 blocks. Okay, it did find these. So it was a distance thing. Okay. I need to maybe expand the distance. Well, what about that one there? Is it done already? Yep. So let's take a peek at the algorithm. Pause it. That would be LV pump. Now, initialize
the thread pool here, I spin off a thread to actually check the fluid. So the thread or the fluid check is done on its own thread. I'm just trying to figure out here where. Okay, so get fluids. So this call is what actually looks for the fluids. Yes, you have to use the pump to get rid of the fountain. That was the point. So step 1 was use pump, clear out the service stuff. Step 2 was build the derrick, get the derrick to pump and build well casings. Right, you're pumping out what's below. Right, there's a bunch of oil below. Right, so you're not going to run out of oil anytime soon. But the derrick will get well casings. It'll pump as it goes out. Right, it'll pump whatever level it's on and keep going as long as you have well casings that you give it. And then once that's all the way down to the well, then you break the derrick down and you build the pump jack. You build the pump jack over with the head over the top of the well, and that will pump oil from the well. So that's the whole process. That's what we're testing right now. Okay, so why? Okay. Only add full height fluids. Fluid positions. Fluid sums. Below. Okay. To check. Block position. So this walk blocks, this is a built-in function that allows you to iterate over blocks a little bit faster. It basically, from what I understand, it basically copies whatever volume you give, right? The start and end positions. Whatever volume you give, it just copies it into a sort of a temporary area and allows you to iterate on instead of trying to iterate over the whole world. So it's just a much faster way of doing that. Okay, so block ID is liquid code, Manhattan distance. I think let's bump this up. I want to see what happens when we bump that up. Okay, so fluid position equals new fluid position. B check dot below. Below. To check dot add. This is what? Wait. If below dot Manhattan distance, that's fine. So what this does is it ties this block below right? It's the block directly below the pump. And I'm looking at the Manhattan distance. So let's actually bump that up to like 80. Because Manhattan distance is a little wonky. Okay. Below dot distance 2. B check. So we're checking the block position and then the dimension well, I'm going to leave that alone for now. Although I really shouldn't. Below dot dimension. This code I've written a long time ago, so I'm just kind of re-familiarizing myself with it. Can't these pumps stay in one block and suck everything as long as you're providing tanks? Yeah, that's what I'm working on there, dude. Like, I'm actively testing this. I'm actively testing this to fix it so you place the pump. But the pump is going to have to be the lowest place because the pump will only pump fluids at the level right below it, right? So that level or above. You're not going to be able to pump fluid below the area below it. So that's what I'm testing. So yeah, I'm actively trying to get it fixed. I'm trying to figure out why it's not pulling the fountain, which is weird. It should have easily been pulling that fountain. Because I'm calculating the distance. And I'm doing that because I want to grab I want to sort the list by the distance. Okay, so fluid positions that contains that. C block that liquid level equals 7. If it's 7, then fluid positions dot add. If it's not 7, fluid subs dot add. And then to add dot check. To add dot add. What would I do with fluid subs? Why? What do I do with fluid subs? I already add it. To add. Why do I need this? As just another thing to check? Yeah, I think I just check it. Because if the liquid level is less than 7, which means it's not a full block. Okay. Add range. To add dot count and fluid positions dot count is less than 10,000. To add to clear fluid subs. All right, fluid subs dot count is greater than or equal to 10,000, which shouldn't ever happen because we already checked this. But this could happen because this is less than 10,001, so it could equal 10,000. And if it does, then it's infinite. And I don't yet have like a whitelist, blacklist sort of situation here to determine that. Fluid position dot sort x dot distance compared to y dot distance. It should be finding that. So let's hot reload that and see. We break. And replace. 16 blocks. Okay, we found 16 more blocks. Oh. I just saw this drop. Hey, it's dropping. It was the distance. So it probably grabbed blocks like up in here, right? But because of how fluid works, it didn't go away because the fluid was the source block was actually inside here. And the way the fluid works is a little wonky. It's very, very much like Minecraft fluids, right? So now we have the whole thing dropping down. So yeah, I'm gonna have to tweak that. I'm gonna raise that Manhattan distance, because Manhattan distance, if you guys didn't know, Manhattan distance, another shorthand name for Manhattan distance is taxi cab geometry. So if you think of a city grid, right, and a taxi cab drives on the roads, well, that is what Manhattan distance is. Is it saying, in order to get, let's say you're on this side of the block and you want to go to the kitty corner side, right? The Manhattan distance is actually 2, because you're going down one side and over one side. So that's 2, right? Instead of it being the distance that is as the crow flies, which would be, whatever that ratio is. It's been a while since I've done my geometry, but the hypotenuse there is going to be, whatever the ratio is for that. Well, it's going to be 2, and so your Manhattan distance is a fast way of calculating distance that doesn't involve a square root, and the square root is really where it is. But then the distance 2 that I do is actually calculating is actually calculating using the square root. And I call that once. I don't call that multiple times. So I'm going to just verify this is dropping. So yeah, by increasing that radius, the Manhattan distance, I might want to make that even higher. But I want to see this drop all the way. Make sure we really got all the things. Takes a while because this is a lot of fluid. But I think that's all. Right, we have that. And that. Because even though when you break it, it looks like it spills, it actually keeps its inventory. If you want to empty a tank, by the way, just give yourself a stick and smack it with a stick. Because, yeah. I have added a way to be able to clear it out. Okay. Yes, plastic is one of the items you'll be able to eventually make. We'll have all sorts of plastic, you know, all sorts of different colors. Okay. That's dried. And this is down to the last bit. So. Now. Wow, peridot rock. That's pretty rare. Okay. Now, I need to build the derrick over the top of this. So you can come down here and see just how much oil is going to be in here, right? Here's your... And then coming down even more. Let's get in here so we can take a breath. And we're coming down to this right here, crude oil. So you can see 362,000 blocks inside of that. That's what the whole point of all of this is getting in there and getting some of that.
Another question from Got a Chance.
Let's see. How about natural gas? Gas, I mean, that's essentially what LPG is. So this right here, that's essentially natural gas. I need to use the bathroom. I'll be right back.
So in other words, it won't be an independent... Oh, it looks like he's going AFK for a sec. Yeah, natural gas won't be an independent one, but it'll be refined from the crude oil.
about that. It was at code red status. I couldn't put it off anymore. Getting back to your question, yeah, LPG is liquefied petroleum gas. You can't, I mean, okay, I'll try to be careful with how I say this. Simulating gas, okay, is not advised in a voxel game. Right? So, because of just how much you would have to simulate, there was a mod ages ago for this game, where it simulated, like, if you had a campfire in a house with no chimney, it simulated gas buildup, right? Like carbon monoxide in the house, right? But it even a small volume destroyed performance of the game. It just eliminated it altogether. It was horribly bad. So the problem is, when you're simulating in a voxel environment, a huge amount of stuff, like a lot of voxels, it just completely destroys game performance. So you can't really do it. Even a supercomputer would have trouble simulating gas percolating, and sort of spreading in an environment.
Apparently, there's a new version of that mod. One to go.
Yeah, and no matter which way you're going to cut it, it's going to destroy performance of your game. This is just how it works. Okay, so I want to build the derrick, and we are going to, we're going to cheat a little bit, unfortunately.
Many games essentially treat gases as a liquid that just floats higher than most liquids.
Right, but the problem isn't the simulation. The problem is the volume. Like, this game is not simulating the fact that I'm breathing air. It's just detecting that I'm in air. But if you actually wanted air blocks to be gas blocks and actually simulate how much gas is in each block, and when I breathe out, I'm breathing out carbon dioxide, and that has to percolate, and you're literally needing to simulate billions of voxels, and it's just, you can't do that no matter which way you cut it. There are cheesy ways to do it. There are ways to do it that make it make it a little bit more abstract. Okay, I gotta concentrate here. Derrick, give block. Vent engineering. BEMB Derrick built west. And I'm gonna cheese it. Of course, my power's over here. There's the derrick. Okay. Before I reform it, I wanted to take those out, because when you reform it, right, it revalidates itself. We're going to need a chest with some item pipes. Let's reform it. Okay. Okay, I'm going to take old tank. Okay. Now, if I wanted to clear this tank out, you just take a stick and you just smack her with a stick, and it's boom, good to go. Okay, and then we take that, and we take that, and now we need power over here. Okay, and then we don't need this anymore. How many MV wires do we have? 13 might not be enough. Nope, it is. Excellent. Okay. So, this thing is basically asleep. Because it's saying I want well casings. It's like, hey, I want some well casings. Where are my well casings? Well casings. Give block engineering well casing 100. Well, I have a breakpoint in here I didn't even know I had. Ooh. Okay. What happened here? Stack overflow exception. Excuse me? One frame above this was repeated 16,000 times. What? What function am I in? On sim tick. All right, where current layer dot count, right, is 2. Remove next one. Which is 31 108 78 2. 31 108 78 2. Why did this call current layer dot remove what? Equity comparer. Let's see. Quality comparer. Well, why did this get run? So it hit this. Can we close this, please? If LHS equals null, return RHS equals null. LHS equals RHS. left-hand side, right-hand side. So why why oh, just go away. Why did this get into like basically an infinite loop? Is it because of this? LHS equals RHS. That can't be right. LHS dot equals RHS. This is weird. It for some reason got into a infinite loop of some kind. This is weird. What's funny is I basically had an object that did this. I invented the object twice. Position equals other position and distance equals other dot distance. Okay. How about instead of doing this, if LHS does not equal null and RHS equals null, return false. Return LHS dot position equals RHS dot position and S dot distance. No, God dot distance equals RHS dot distance. I think, yeah, this was expecting. What would be funny if what was happening was that equality that was here, right? This dot equals this was coming down here and doing a check, then that would call this, that would call this, that would call this, and it was just bouncing back and forth. So let's see if that fixes it. That was weird. Now I'm probably gonna have to redo a bunch of that stuff because I hate when I have a crash or some exception in the middle of testing because it just the game doesn't save, right? So let's see where it put us. Okay, so it is like let's give it some casing. I need to give myself casing again. Give block while vent engineering while casing 100. There it is again. Static bool operator. This is very, very weird. Yeah. 12,000 repeats. Okay. Let's put it there. What function is this in again? On SimTick. Okay. Current layer dot clear. This is why I needed a testing day, by the way. Because I've implemented a whole lot of things that I needed to kind of go back and be like, all right, now that basically the whole chain is done, I can go back and test how everything works. And yeah, run into weird cases like this. So this layer here, because this is going to call dot remove so it's bombing on this line, but there's only like 2 things in here. So it's having trouble finding. It's basically getting into an infinite loop where it's not able to find okay. So let's go in here. Now we're kind of I'm kind of drilling down into this here. I need to know why it's not finding that object. If worse comes to worse, I'll switch it over to the one that the pump was using because we know that one was working. I just literally pumped an entire thing out. Okay. So the animation is playing because it's actively drilling. It's just out of well casings. Okay. So if we give ourselves, okay, there's the well casings. Give block pop. There we go. So current layer has two things in it. Right? Two things. Which 128.31, 108, 129.478, and 2. Okay, so if we go here, we go here, we go F11, other, okay, distance and distance. Why? Wait, what just happened? Other equals null. Return false. Return this dot distance. How is this throwing an error? How is this throwing an error? The distances are normal numbers. This dot distance equals other dot distance. This is what is going on here? What is going on here? This doesn't make any sense to me. What this is actually doing. This makes no sense to me. Current layer. Okay. Other. An F10 here, which should other does not equal no, right? So we should go to return. It's popping up to here. But why? Why is it coming up here? If left-hand side equals null, which isn't true. No, I lost my mouse. What happened? What? That was weird. Oh. I think I know. Anybody else catch it? Somebody out there has gotta catch it. So what this function does, let me give you a rough idea. This is the equals operator, right? This is the check for equals. Like literally, this is the check for equals. But I'm overriding it here. I wasn't overriding it here, right? We just have the dot equal, like we have equals, but I'm not overriding the operator. So what this is doing, right, is hitting this call right here. Other is one of our objects. Okay? So this other equals null, right? This is the operator. It's coming up here. And then it's doing it again, which is calling this, 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 which is calling this. It's an infinite loop of a check because we never get out of the operator. Because this null check is a really basic check, but the problem is there's like, how do you check for null without calling the operator? I think what we're going to want to do, because this IEquatable here, if we call IEquatable, I'm pretty sure the only thing you need Okay, come on. It's in here somewhere. Let's do a block position. Is IEquatable. And all that wants is the equals. So what I need to do is I need to not overload the operator. Okay. And then the equals block will be a more generic block because I don't know if the operator equals. Let's see if I don't know if block position overrides. Yeah, see the block position. They have to override equals. But they use these operators without overriding the operator. Maybe. Well, let's see. No, we have this. How is this not the same? How does this not run the same thing? Left equals null. This is the same issue. So how does it kick this out? Because left equals null, right? Would call this, then do it again. Which would call this, and do it again. This is the same issue. How is this getting out of that loop? Block position left, block position right. Like, how is this not running that same problem? Because I do with the other equals null. Okay, this is a not equals, but it has this too. I'm at a loss for why or how mine doesn't work, but this one does. Static bool operator equals block position left, block position right. So let's if left equals null, return right equals null. Left should never be null though. But anyway, I'm gonna have to use the bathroom again. How does this work and not cause crazy problems? But mine doesn't. Let's look at the dot equals again. Other does not equal null. How about we do return other does not equal null and I just want to get it as close as I can to what this is. This object favors distance over position. The block position and distance. So when you're checking on like less than or greater than, all it does is check the distances. It doesn't check any of the positions because it doesn't matter. It allows me to grab a big array of block positions and just sort them by distances, and that's just how this works. But this is a weird problem to have. Now, if worse came to worse, I would just eliminate the overrides. Other does not equal null. This dot distance. Okay. Yep, there it is again. It literally, like, this line causes an infinite loop. How does this work then? It's not getting past this call at all. Like, this call is causing an infinite loop because this check is literally the same function. How do you... This is like one of these catch-22 things. How does this work? This other does not equal null. So it comes in here and it goes, okay, return not left equals right. Okay, this equals then comes up here and it's like left equals right. If left equals null. Well, what is this call? This calls equals. So then it comes up here and it says, hey, left equals null. How is this not an infinite loop? How? How does this work and mine doesn't? I'm at a complete loss. If something is null, right, I can't in here. The equals operator, these are fine because these are outside of this equals, right? These are comparing either direct numbers, integers, floats, or whatever. This breaks everything. Or it should. Now, this equals. It's one thing I don't have. No, maybe I do. Equals, yeah, object here. But operator, I don't have that. Is this my problem? Right here. Position. So if I do this, because I'm calling, so block position and distance other equals object as block position and distance. And instead of doing that, return other does not equal null, and this dot distance equals other dot distance. Because when I'm doing a null check, that might be being treated differently to this operator here. Left dot equals right. Yeah, if the positions are the same, the distances will be the same. This is so bizarre. This is so bizarre. There it is again. Infinite loop. Jesus. My computer does not appreciate. How do you... I don't know how how is this possible? How is this object not calling an infinite loop here? Can somebody tell me that? I'm going to need to use the bathroom.
Okay.
I'm at a complete loss as to how or why this is happening. I don't know how to kick it out of this infinite loop here. I could fucking type. Like, how is the base game's block position when I do an equals comparator on a block position? How does this not devolve into an infinite loop? Okay, this is my code basically mirrors this code in terms of like this section here. This call should cause this to be in an infinite loop. So what I'm thinking is this decompiled version is not what the actual code is. What it actually is this. Object.reference equals. Basically calling a different function. Okay. Now, yeah, because I just pasted the class into an analyzer, and it found it right away. It was like, they found the same thing I found, the infinite loop. So this reference equals are determining if the specified object instances are the same instance. Okay. So it's determining if the null obviously will be false. If if left-hand side is not null, but right-hand side is, right, then that's obviously false because it's null. So so now okay, so now if we do returning true. I need a steel. So if we go down, wait, what is happening right now? Well, it got all of these. But why did it miss? How did it miss these? One of the things that's really hard to debug in this process, right? This making mods like this. One of the hardest things to debug is the fact that the game is ticking really fast behind the scenes, right? The machines are ticking really fast. So any given tick, you're not guaranteed something to happen. So what's difficult about this is to debug something like this, right? Very, very, very difficult. Because why did this happen? Well, any given tick, it could be doing that check. This should have built a casing here, it should have pumped all of these out, but it didn't. Why didn't it? Will you stop moving, for Christ's sakes? And the other thing that really bothers me, is the, this is still flowing down, yeah. When you look at liquid, it doesn't actually highlight the liquid. Right? So it's like, how can I tell what liquid is there? I don't know. There's got to be a way to do it. There's got to be a way to highlight the liquid, but I don't know what it is. And I can hear myself going through many, many, many different... Oh, I'm always in the wrong... it's... How is the power still being delivered? Yeah, I knew that Derek needed a crazy amount of work. This just bothers me. This has got no network. Rated power. Delta time. Max power per second times delta time is the rate. Can extract power. Oh. Rated power is insert is true. Stop. Is insert. That's why. It was not taking power out because I had missed that this was an insert call, not an extract. Oops. Oopsie. Okay, so that should have fixed that. Now the problem is the fluids. I have a problem with my logic here, and I think it might be down to what we're checking here. So my operator equals checks position, because at the end of the day, positions that are the same will be the same distance. If one position equals the other position, the distances should be the same. So I think my equals here if reference equals other null, return false. So we can change that. So that I want this dot position equals other dot position. Because the distances are good for comparing. Yeah, they're good for comparing or sorting it by distance. But I think as this thing is going down and doing that, all of the distances that are equal are getting removed because of how I did this. I need to remove the position, not based on distance. Equals object. Okay, I can go back to what I had here. Because what I had here was actually good. Like that. Which calls this, which then bombs it if it's null. So that's good. Because if this cast isn't valid, right? If this thing can't be casted to this, then it's null. And this just check grabs it. Not sure what get hash code does. Distance. Okay. So now sorting less than or equal to, or less than or greater than, is based on distance. Equality is based on the position. Okay. I'm hoping this fixes how this thing is run. The other one was the way that my block placement let's get back in. What? Wait. This is wrong. This is very wrong. I don't know what I was thinking there. God. Fine. Just stop debugging, for God's sakes. Yeah, rated power that was the wrong call. It's based on max power per second times delta time, not a rated power. That was all bad and wrong and all the things. So initialize, where are we at here? Position. Well positioned. Okay. Build pumpable fluid layer. We need to start debugging this function. I think I've fixed the power. I've fixed the power. Okay, so start block. Start block is a liquid. Okay. And then we can skip down to here. Okay. Current layer. Are valid. You can see all the distances. This is why I was thinking like all the distances were messing up, because yeah, some of these are identical distances, right? So the ones that are identical distances were being removed because of that equality check. Yeah, a bunch of these are the same distances. So so now the entry here, we've got the block position and then the distance. So then we come down here, we can run to cursor. Now we have 32 valid blocks, right, at all the same height, that's important. But the other thing that's important is the ones that are identical in distance. Oh, look at the power. Okay, why? Why is our power at 2 billion%? Power is somehow it's maxed at 18 quintillion power. What the what the hell happened? Current power, percent power, electric duct max power. Okay, let me just. Okay, electric duct current power, electric duct max. How did current power get to be the max value here? Okay, we're gonna need to reset. I think yeah, we're gonna need to reset. Oh, it did not like that at all. Okay. Distillation core. That's the distillation. Where is it? Derrick core. There we go. And then we want a concrete. Okay. Now let's reset the tank. Now, let's do a block there so we can put a block here. And you can't actually place these are actually going down. But what we can do is place a thing here. Okay. Now, when I form this, it's going to automatically try to find yeah. Cat, I really don't want to deal with you right now. I really don't. She doesn't care though. So yeah, as soon as I build this, it's going to. Okay, so this should be fluid all the way down. Now it won't be source fluid. I don't know how this thing handles. Let's take a peek. I basically want the game to save. what this is right now. Let's look. Get first pumpable position. What is it, Luce? Huh? What is it? You don't have enough lap. You need more lap. Okay. Now. Get pumpable fluid layer. Why is this not triggering? Why is this not triggering? I've literally... on thing. Just because you're animating. The hell is wrong with this thing? It was working fine. Drilling at 3 depth. It should be drilling at 2 depth. Okay, let's come up here. It's on. Okay, why is this not triggering this? Why is it telling me the code changed? How is that possible? Doesn't help that the game takes an ancient or a serious amount of time to start. I don't even have that many mods loaded. Like, just basically the mods that I maintain to test and stuff. Okay, so start. Start block is liquid. It is down 6, so that's not a full block. Jesus. Okay, let's run to cursor. To add. See, 108 and 109. What? How did it find 8 blocks? Let's run to this cursor. Are valid. Are valid dot clear. Current layer. Okay, so I have a logic progression problem right now. Maybe. Let's see if we can't. Well position. Current layer. Dot count. I need to stop going in here. Where is the call for that? Somewhere in here. There it is. Run to cursor. Current layer dot count equals 0. Okay. So the problem is I need to progress this call here. I need to progress the well. Don't do that. If we still have nothing to pump, we might have to progress the well down. Okay, so how do we do this here? So essentially, like, we pump that first layer. The other thing we need to do is only check. Oh my god. I hate when my things are so far apart from one another. Get first pumpable position. Yep. Right on cue. The lap goblin. She comes over here, bugs my leg, right? She like hits my leg, say, "Hey, I'm here." And then she leaves. Eats or drinks or takes a dump, and then comes back and jumps in the lap. So it's like she comes over here and is like, "Hey, are you there? You're in the chair. Can I come and sit with you?" But later. And then she has stuff to do first. Yeah. Lap goblin. Lap goblin. So I also need in this call there's a bunch of logical stuff here that I need to figure out. The purge have begun. I gotta give the chin scratches, of course. How do I want to do this? Somewhere in here. Why does it add another parenthesis on the end of that? That's so stupid. The IntelliSense has gone backwards.
Isn't it funny how so many things when it comes to tech have gone backwards?
Yeah, the reliance on like some sort of AI engine, whatever they do behind the scenes, right? IntelliSense used to have very explicit things that it looked for, right? Functions that you used a lot, procedures that you used a lot, variables that you used a lot. Now it's just like YOLO, like, wow, we're just gonna throw you a bunch of random shit and just hope something sticks. It's like there's no intelligence behind it. There's no logic behind it. It's just like the very basic, like, oh, this, you have an L, I'm gonna show you everything with an L. And it's like, no, that's not that's not useful. Cat, what's your dealio here? Now she's in a position where I know she's not going to sleep.
I find it weird that search engines have taken a step back. And this isn't the first time either. The most recent iteration, I think we can blame AI, but there've been others where it's like I used to actually be able to find stuff. Now, nope.
Yeah, and one of the reasons for that, especially with Google, is Google doesn't want you to leave Google, right? Google
Yeah.
wants you to stay in their ecosystem. And so what they've done is they've built a system that summarizes searches, right? So when you do a search, it doesn't actually search for what you're looking for. It tries to summarize what you're looking for. So you never click a different website. You're always in Google. Because then they can monetize your shit, right? So keep them in the ecosystem. So I know that like information-based websites have dramatically lost the traffic because of that. Because Google, instead of sending you to a page with the information, like Wiki or something like that, let's just genericize it, right? Instead of sending you to that page, it just summarizes it for you. And it's like, here's the information. And for most people, that's fine. But if you're the kind of person that has a website that has a bunch of information on it, that you have a little bit of advertising, that you generate money, that you can actually pay for that information, now Google is removing people from going to your website. And now your traffic plummets off a cliff, which causes those sites to then go out of business, right? But Google retains the information. They've got it already. So now, right, you've centralized the data, and now there's no ecosystem that it's one of these feedback loops that just ends in destruction. That's all it does. All of these, hey, let's make let's help our customers, actually does more damage. But they don't want to change it because it keeps people on Google, and then Google makes an unholy amount of money in advertising. So their best interest is to keep people on Google, and unfortunately that screws literally the entire internet. Because what percent do you think use Google for searching? A large percent. Okay, so get first pumpable position. We want to then come down here. Block at casing continue. Else, if block at equals 0, I need an area around the blocks. Yeah. So this to do, place casing or search finds error invalid. Okay. So we need block position start equals start. Start look equals start dot add copy. Let's do 10, 0, 10. Oh my fucking god. Start dot add copy minus 10. let's see. It's hard to ignore. Oh my god, of course there's an update. I made the mistake last week before I started streaming of clicking like update now, and it was like a 3.5 gig download. It was just like, oh, it's not a small update. They're usually multiple gigabytes. Even going with tiny little changes in the version number, like, you know, blah.14.14 to blah.14.15, it's like 3 gigs. It's like minuscule changes are just crazy. I mean, it took forever for that update to finish. And then when it finished, it was like, you should reboot to make it better. Or to ensure that things are working. It's like, god damn. Really? Okay. So here we are a week later, and boom, there's another update. Of course there is. Okay, so what we need, we grab the casing block. Now start.y if casing equals null, return null. Yep. Nope. There we go. If we need casing, so if casing is null, bounce. We don't want to come in here. Luce, will you decide what you want? Start that down. Block at. Damn it. See, this is. I offset the start and then I move it down. That's not ideal. So we need to move start dot down to the end. Why is this squiggly now? Unreachable code. Oh. What? No. If casing else. Huh. Okay. That's a problem. I need to go up one. Because I'm basing it off of start, but I moved start down, right? So I take the starting block, I grab the block that's there, and then I move this down. But I check that block. If that block is casing, right, I've already moved start down, right? So the whole thing goes around again, and I look at start.y. However, if it's not casing, this is what this continue is. If it's not casing, then I need to look at a bigger area, start look, and end look. So I need to, because I've already gone down one, I need to go up one to check that area. Because I base it off of start, and I've already moved start down one. So I need to go up one, which is there. So then we want to do a walk blocks of this zone. And then we want to say, how do we want to do this? Bool bound fluid equals false. sappy.world.blockAccessor.walk blocks. We want to start look, end look. We want block int. Forgot the syntax. Delegate, there it is. Sender order false is fine. Yeah, I actually want this whole block. Well fluid code. Problem with that is it may not be set. If well fluid block code equals string.empty, I need to remove this, unfortunately. Basically, like, repeat what I did here. Because if we find a liquid, then I need to set well fluid block code equals dblock.code. Well fluid code equals dblock.liquid code. Okay. And to speed this up, short circuit it. So the very first fluid we find sets all these values, sets this to true, and then it doesn't check anymore. Right? It's making it very, very fast. Because remember, it's going to check 100 blocks. It's a 10 by 10 area. So it's going to do that. But once I find a fluid, it just goes through because it doesn't do anything after that point. All right, so then if we find a fluid, block at fluid found, fluid codes are all set. Right, so we walk it, and again, it's only a 10 by 10 area, but yeah, the only caveat to this is if there's some like a single water block, right? If the well is being validated or a game is loading, so you have an edge. This is a potential edge case bug. This is why when it pumps from the outside to the inside, because it's like I need to check this. If block is 0, so this whole section if it's 0, if with the block we're looking at is air, right? Something weird happened. And I need to look a little further afield just to ensure, right, that just to ensure the fluid is found. Well fluid block code equals string.empty. Well fluid block code equals decode. Then I need to do an if well fluid code equals dblock.liquid code. And then dblock equals block at equals dblock. Oh my fucking dblock. Okay, let me just think about this for a second. If well fluid block code equals string.empty, we haven't set it yet, and this finds it. This finds a liquid. Do I save this to disk? I do. Yep. So I save what the fluid is to disk to restore it. So when it loads in, it'll already be set if you've pumped anything out. So that's good. So if it finds, right, so this block won't trigger. If you load this thing in, it won't trigger, at least not at first, because there won't be any fluid there, because the block code is already set. It's already set to like crude oil. Then, if this block isn't triggered, then this block does a check. If the liquid that we're finding, right, we found a fluid, but the liquid codes aren't the same. If the liquid code equals liquid code, block at equals block, and then we want to found fluid equals true. And then just skip it, because dblock, it actually found it. So let's see. This might be why we had skips. That might be why we had a couple skips in the line. Because we remember we do a start and then we immediately move it down, but we're on the block above. This is one that we're processing, but we've already moved it down. So when we place that block, we're placing it in the wrong spot. Okay, so block at that ID equals 0. So D block, or block at equals D block. Input slot.empty, casing code. Set the casing. Yeah, this is a problem. What we need is to do this again. Now it's saying it's unreachable. What? If it's air, process an area, right? If the block we're looking at is air, let's look at the area. If we look at the area and it's still air, right? If block ID equals 0, if it's still air after we do this, which means we really didn't find any fluid, it sets the block that is what I was missing. There we go. Yeah, set block. But if it's not air and it's a liquid, block at is a liquid. It does the checks again. Block at code. While fluid block, return start dot up copy. Yeah. It was returning the wrong block. Because we bumped it down. So we need to actually return the layer that is there. Get first pumpable position. Okay. So block at is what we set up here. Liquid code. If block at is still not anything. Oh, we check to see if the block, if it's a well, then well completed true. Get block entity. Again, we have have this. But again, we have the start. Set block. All completed. Get block entity. So again, we have. This is looking ahead, but we don't want to do that. We want to. We want to see what we're looking at currently. Okay, so now we have to see if block head ID was 0. Check the area. If it's still 0, we want to, well, this if it's still 0, we're checking the casings. We're making sure we have some casings. If we don't, return. I think if input.empty, input.item stacked to a collectible or code. So now yeah, we want to bounce if we don't have any casings. Same with this. I should actually put this be better in the while loop here. Like, don't even. Why is it so hard to find a way to trim trailing spaces? I've looked many times to try to figure out a way to do it. All the searching tells me it's possible, but evidence to the contrary. I have not figured out a way to do it. So yeah, if we run out of casing, just stop doing all the things. We don't need to do anything. Okay, Kat, you're back in my lap after a hiatus. I don't know where you went. Yeah, I know your rhythms. You're the same routine every day. Okay, so when we go into this, first pumpable position. Come in here. Grab the block. Move start. If the block is the casing, then continue. If it's not casing and it's air, check the area. if we find a valid fluid, then I think I want this center order true. I'm hoping it does what I think it does. I hope it starts at the center and spirals out, because that would be the best way. That would be the best. Not sure. Okay, so if it's air, check the area. If we check the whole area and it's still air, try to set a block. Try to set a casing. Remember, we've already moved down one. And then continue, which comes up here and starts again. But we've already moved down, so this gets the next block down. Now, if it's not air and it's liquid, if the liquids match, well, if the liquid, if we haven't set it yet, it would be the case right after you build it, right? It's going to start looking below it right after you build it. So, we have, if it's liquid, start needs to be .up copy again. Yeah, stupid. Yeah. All right, so if that's not empty, if we're starting it already, then we need to look at does the liquid that we match equal what we need? And if that's true, then send back. Else, there she goes again. If it's a liquid. If it's a liquid but not what we want, then set up, again, it could be water. We could have water coming in, and so then continue. If it's not a liquid, so it's not a liquid, it's not air, and it's not a well, we need to return, which means we hit it's not casing, it's not air, and it's not liquid. We need to bounce because there's like a rock or gravel or something in the way that prevents us from digging. Okay, so that is actually right. Now, if we get through this whole thing and we don't hit anything, we don't hit a well, we don't hit anything, right? It's the problem is now we need to return null because nothing in here works. Okay, so with that, let's go back to our run here. So validate well. God, I hate when my voice cracks. Bothers the hell out of me. This might need a little massage. But we do get, we do call to get first pumpable position. Okay, so let's get back up to here. Get first pumpable position. We need to do well position equals. Okay. Okay. Now, let's see. Did we break it more? Did we break it more, or did we actually, fix it? Sometimes it's a dice roll. It's a coin flip whether or not I broke it even more. I'm kind of curious. I'm going to see if I can go to the let's see, Inigo Studios, and I'm going to do a search for block position. I just want to see if they implemented those overloads the way that I did, and if the decompiler just did something weird with them. Okay, operator. Add. Operator. Operator equals. Yep. Reference equals. So my decompiler, dnspy, stripped out the reference equals. That was the difference. Okay. Good to know. Good to know that dnspy is not the be-all, end-all of all the things. Okay, so well positioned, we have that set. Current layer obviously is 0. Okay. Build pumpable fluid layer might have 0. There it is. So now, well positioned, if we bounce into this, oh, yeah, we don't have, damn it. Conditions, input, slot dot empty, not 5. Yeah. So this is bad and wrong. I'm going to grab that. I think I have a way to smack this. There it is. Okay, well position. Current layer. Current layer should have more than one, though. Crude oil D7. No, that's wrong. Portion stack. This I think is what the problem is. That is a problem. Crude oil. Current layer dot count. Drilling at 2 depth. So why is it not drilling at 2 depth? Well positioned. Current layer. Current layer is still 0. Well positioned. Let's go to there. Okay. Block at crude oil D6. Block at is not that. Block at is not 0. It is not 0. Block at is liquid. Should be true. Fluid block code is not 0. Or empty. Block code, I need to remove that. We only care about the liquid code. Okay. Well positioned, moved forward, but we still don't have any there. Right? Block at is now is the same thing. So I actually need to stop this because if we're a liquid, yeah, okay, so if we're a liquid, this returns the position of the well. What is actually looking at and placing blocks? So if we come back up here, somewhere up here, well position, get block, portion stack. The problem is well position. Okay. I know this is like, this looks redundant. it kind of is. But we need to check, right? We need to look at get first pumpable position. If well position is null, which means we just built it, right? Or we just powered it. Then we need to check to see what's below us. But this will build well casings. So after it's built, in the case like what we're doing now, where it's built over, you know, for whatever reason, again, these are edge cases that I'm debugging here. Current layer, which means whatever we're on, current layer is not a thing. Are we calling on our initialize? Well, position is not equal null. Okay, so we are calling it. Current layer, we are calling this build pumpable fluid layer. So let's go to definition on this. Start block is liquid, get well at. True, return true. Okay, so to check. So this is trying to build the fluid layer. Okay. Liquid level. If dblock.liquid level equals 7. But the problem with that is we also need, we do this up here. Okay. dblock.liquid code equals well fluid code. Okay. So we already checked that. We check to make sure it's level 7, which is the source block. So, yeah, this should be fine. But build pumpable fluid layer. I don't think this sets... This does not set any well casings. This one does. Or it should. Set block, yeah. Because if it's air, and we check around, there's still no blocks, and it's still air, then set the casing, and then continue, which resets, it comes back up here. So it should just go down and find the first pumpable piece of fluid that we could find. Okay, so coming back up to our tick event system. Get first pumpable position. Well position. Get first pumpable position. This could return null. So there's a potential edge case crash here. If well position equals null, return. Otherwise, build pumpable fluid layer. If not, return. Okay. So let's try this again. Okay. Well position is not null. Current layer is 0. Build pumpable layer is still 0. So what happens when I just do, this is depth of 109. This is still depth of 109. Okay. Current layer, R valid 0. R valid clear. But why didn't it? Wait, this doesn't make sense. Block at is crude oil. Yes, but it's not 7. Okay. I'm starting to see the problem. It's a liquid. The liquid codes are right, but the levels are not. Block at liquid code equals fluid code. Right? So, yeah, this is true. Well fluid code equals B block code. Okay. And then we want to do and D block dot liquid level equals 7. Okay. Now we need to look at if block at.id equals 0 or block at.liquid level is less than 7. Okay. Yeah. I messed that up. I messed that up by changing so much in one shot. Because it's looking down below and it's like, oh, there's a liquid block there, but it was liquid level 6, not 7. So the get first pumpable position Okay. So if the block is either air or if it's liquid and the liquid level is below 7, check the area around it. If it's air, specifically, set the block and go forth. Block at is liquid. And block at liquid level equals 7. So if it's not 7, well, yeah, this kind of foobar's. Because then, if it's not 7, this sets the block. If we run into a liquid block that is level 7, which is a source block, then we reset the block at variable, which should allow all of these to pass, right, to return that value. Otherwise, it should progress downward, meaning we didn't find any liquid source blocks of the liquid that we're looking at in anywhere around the well, then go down. Right? Set the well, move on. Okay. Let's try this again. It's funny how you kind of get like stuck on little logic snarls like this a lot. Some machines, right? Some machines are super easy, right? You just take an input, you process, and you spit out an output or whatever. And then some machines are just like, oh Lord, like holy cow, like this is very complex behavior. Current layer dot count equals 0. So we're going to try to build pumpable layer, but current layer is still 0. So now this should knock this down to 110. This knocks it down to 65. Okay. Build pumpable layer. Let's go here. Let's run to here. R valid 1. Current layer is now okay, fluid block. B props. Leaders, blah, blah, blah. This is pumping the block. Calculating how many portions. Current layer dot first. Right? Set block. Current layer dot count equals 1. Inventory of 0. Dot stack size. Where are my slots? Give me my slots. Here they are. Well casing. Yep. Set block. That was the last one. It's funny that I had exactly electric power remove. What? Power per second. Well, we just rolled this over. Did I not do a check to see, like, if we had enough power? Yeah, we have enough, like, right here. Current. Oh, right. Okay, let's. I made the same mistake here. Current power is less than electric dot max power per second times delta time. And then I want that dot. Oh, derp. I do the +1 here just to make sure that we're not doing anything quirky. If new state equals sleeping. So this puts it to sleep. Okay. Now, depending on where the game saved last. Okay, we're still at 109. Current layer. Okay, so this one now should go through. Oh, it's only saying we have one. Set block, take out, continue, go in here. Excuse me. Oh my god. Is that the wrong slot? Yeah, that was the wrong damn slot ID. Well, that's how it was able to do that so easily. It wasn't actually removing. I wonder why that happened. And is that bug somewhere else? Inventory 0. Okay, so that's not. Position is null. Head position dot down copy. Block at is not crude. We're down to 106. Block at is still crude. It is liquid. inventory of 0 dot takeout. Now inventory of 0 is empty. Or is it? Let me see. Slots. Yeah, it's literally empty. Okay. So this should be true. It is. So this returns null. This is set to null. Position has no return. Okay. Holy Moses, that's slow. Fluid block. Current layer is 1. Fluid block is 7. Portion per liter. Portions per second. Available portion. Inventory of 1. Next one equals current layer dot first. Set block. That clears the fluid. Current layer dot count is 1. Current layer dot clear. Well position dot down. Casing. Set the casing. From 4 to 3. Oh Lord, this is going to be... Okay. $173. Okay. I just don't know why. It's like it needed a block update. That's what it feels like. I'm missing a block update. Like a trigger neighbor block update or something. I just want to see when this fluid gets all the way down. So it's 47 depth. I have 3 well casings in there. So if I put these in there, that's 6 well casings. Now you have 50 well casings. Good. I mean, I could add a specific trigger neighbor blocks. I just want to see what happens when this thing finishes, if it places it down and moves on like it should. Boom. Yep. Now, these blocks, right, again, are going to be, I hope the fluid is coming down slowly but surely. It's just taking them a while. A long while, but you saw that once it finished, it popped the well casing down, and now it's working on this new layer. Which there is a healthy amount of oil just in this bubble. I mean, there's many thousands. So, or I should say, many thousands of blocks. There we go. We're finally almost down here. My tank is probably full up there, which is why it stopped. All right, how about these other ones? Okay, this is almost there. That one's done, and this one is... Why is this one still being derpy? Let's clear that. Ooh. Where am I? What's the hotkey for the... There it is. No. Yeah, this was full, as I expected. There we go. Okay, I think we've ironed out a bunch of the kinks with this. Like, this was a very untested multi-block, so this is why I wanted to do an entire, like, testing stream, because finding issues like this allows me to, you know, for the next public release, I wanted it as, like, robust as possible. Hence the test. And there could be edge cases, there could be weird behaviors. There's a thing with when the block is animating, when the machine is animating, and you break it, I'm going to need to figure out how to fix that, because we need to stop the animation. We need to stop the animation before we break the multi-block. You missed two. Ah, that was the block update. Yep. So when I take that last one out, right? When I take that last one out, I need to trigger a block update. So yeah, right now this thing is animating, and if I broke it, it would probably not like me at all. So what I'm going to do, first of all, let's fix a potential. Where are we here? On SimTick. Current LaserDart count equals 1. Stack size, blah, 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 blah. Where is the set block? There it is, right here. Set block. This, hopefully, right? Because we set the block to air in the fluid layer, but then we need to trigger that block update. I don't know, right? I don't know if the fluid layer is casing. When I place a casing down, I also need to do it. This should trigger the block update, but maybe not. Okay, and then oh man, there was one other thing. Oh yeah, the multi-block. Core entity. Multi-block core block. On block broken. Multi-block MB block broken. Go to. Okay. So we need EE multi-block behavior. Let's actually exit while I do this because I want it to save whatever state that it was in. Save it to disk, right? Then when I go in and break it again, that's going to be my new, my new starting point. So MB on block broken. So this is a multi-block on block broken, right? This is what's called when you break a multi-block. When I do this, what I need to do is detect whether the block is animating or not. And I need to stop that animation. So if we go to, say, let's go to the Derek, because I know the Derek has an animation, and then the set state. Machine state. I need to somehow make this a more generic thing. Oh, hiccups. Multi-block entity core. I have so many. Goddamn. Can we clear a lot of these off here? I should look at that pump one last time and increase that. Let me just pop that open really quick. Somewhere in here. There it is. Manhattan distance greater than, let's say, 110. It's basically like 50 blocks over, 60 blocks up, right? Or 10 blocks over, 100 blocks up. So that's how Manhattan distance works. Every direction is more distance. Okay. Now we can peek at animutil. Let's go back to here. Now we need animutil. So this core I thought for sure. Thought for sure that was what I needed. No. What is the base? Electric container BE. Animutil. There it is. What? Oh, it's protected. Why is this protected? Look at all those references. All the references. Yay. There's the animate. I knew I had it somewhere in here. But it's part of the behavior, not part of the interface. So... but this should be, yeah, Animutil. Okay. Um, I'd work on Band-Aid fixes first. um, so now let's really break stuff. Right. So this thing is running and it's animating, which is not. It's not a good idea to break these when they're animating, but this is what we're trying to fix. So when I break this, it should stop that animation, which should swap the blocks back. We should jump into here. Oh, Jesus. I love when it does that. Stupid fucking game. It literally just is like... It keeps running the event over and over and over and over and over again when you're debugging. Forgot about that. It doesn't just run it once. When you're debugging, it loops it. Many, many, many times. So one block break event becomes 50 block break events, right? If you're not careful. Which is it's just super annoying. I don't know what to do about that, but that's a base game problem. I really should make those make a sound when you build with them. There it is. So now probably going to need to give myself some more MV wire. Yeah. Really? It's dash. Oh, why do I keep doing that? Dash MV power. There we go. see, this is a problem. It's animating. It's a big block, right? So the animation, I don't know if it's like a base game, like fundamental problem. Because if I leave, and it's always nighttime. Always. Even when it's not nighttime, it's nighttime. When I'm debugging. Always. How do I get this thing to force it to redraw? It's like if I exit and come back in, it's going to draw it fine. Right? But for some reason, it's drawing that. Right? That is drawing which is weird. Because if I exit, right, and then just go right back in again, it's going to draw it. See? So if I break this, and yes, you do lose. There is a net loss of wire. That is by design, so people can stop. Animation stops. Animation starts. If you guys have suggestions, I'm all ears. Or eyes, whatever. I don't understand it. Unless I have some weird something somewhere that's mapped improperly, I don't know. Let's look at the actual derrick. So when this thing kicks off, we have the animation and we have the code. Well, let's peek at the shape. Keyframe. Drilling. Code. Drilling. I should slow that down. It wasn't meant to spin as fast. It was spinning. Um, okay. I'm just really curious. Lock entity animation util. Hmm. I'm wondering if I'm using this wrong. Rendering stuff is not my specialty. As I'm using a base game animation util here. Animatable. This done animation. What sets the animation code? Okay. Bellow animate. Let's see what I'm missing. bellows. Oh Lord, where would that be? Mechanics? Where's the bellows? Block types of wood. Okay. Attributes. Bellow animation. Animation code, animation speed, animation by type. Okay. And animation sounds by type. So animation is bellowing, code is bellowing. So it kind of does what I do is I name the code the same as the animation. So reinforceable, no, bellow animation. So it's pulling this as the metadata, right? As object metadata. And then the decompiler does some shenanigans here because it's just like, hey, make this object equal that object, and then don't use this object. Like, why not just use this object in here? Why make a copy of it? Seems kind of redundant, but yeah, it's the decompiler gets all discombobulated sometimes. So I don't know necessarily how to force draw the block unless there was a way to do it in here. I mean, I'm doing a mark dirty on it. So what's happening with the Derek? The moment it's powered and it turns on, the animation, it comes in here and is like, let's set it on. Start animation, new animation metadata. This is all the things. Okay. Now I could go in and make, like, redo the crafting animation stuff. I don't want to do that right now. That's just annoying. But when that animation triggers, this is new. At interface. I'm not familiar with that syntax. At interface. It's a variable, but if there's an at on it, I don't know what that means. Okay, but animutil behavior, no, return true. Animation speed, blah, blah, blah. Start animation. Animator. Running animation. These are new. These are very new. Get animation state. Yeah, this object I am not familiar with. Running animation. None of this shit is documented either. It annoys the hell out of me. They've got all this stuff and all of this great API, and none of it is documented. None of it has help as to what it's for, how to use it. Give me an example. Like, it's just like, you figure it out. 90% of my time is trying to figure out how stuff actually works, because there is so little information. So yeah, running animation is like literally I don't know. I'm not gonna. If your Derek disappears, leave the area and come back. or help me figure it out, because I am at a loss. There's an on-tessellation in here. Cache, shape, texture source. animutil.animator. I would love to know what this code does. I would love to know what this code does and why it exists and why you need so many different places. Start animation. Right? You have animator base. Then you have this run anyway. Like, I don't understand how all of this stuff fits together. This is like, it's like putting together a puzzle where you don't know what the image is, and you don't even know if all the pieces go to the same puzzle. There's so little documentation for any of this stuff. And what documentation exists is usually way out of date. So it's like, yeah, I don't understand. I don't understand what this is doing. Why you have a tessellation with an initialized animator in it. Yeah, behavior animatable. Lock entity behavior animation. This done animation, blah, blah, blah. Start animation. Which is what I call here. Start animation. But then there's a bunch of other shit. Get animation state. Current frame iterations. Like, what's the point of this? It doesn't do anything. This object equals this state. If it's not null, then set frame and iterations. And then we come down here grabs the animatable, and then initializes animator. Base.block.code. Bellows. I initialize the animator in the initialize call. Somewhere. Here it is. Right here. If we're on the client side, animation util does not equal null. Animation util dot initialize animator. The animutil again is a behavior. So it's initialized as a behavior when the object itself is initialized, just like the electric behavior. So animation util does not equal null on the client side. So this initializes. It's funny there's no sidedness here because this is only on the client. Tessellation is only done on the client. So none of my other machines vanish when the animation starts or stops. I don't understand. Somebody who actually understands the rendering process of this game might be able to help, but none of my other machines do this. None of the other machines that have rendering, by the way, or animations. They flicker. That they do flicker, right? But yeah, it's not. I don't know. It's just that this block is big enough where it's like, but again, it's just a single block. It's not like it's trying to animate like 500 blocks. It's a single block that has an animation, and I know it's fine. The animation works fine. So let's remove the wire again. Now when I break this, Power drops. The power automatically pops when that happens. Okay. There's the unbuilt version. So we form it. Well, let's break it again. Okay. Hey, that worked. Not really sure why that's getting all derpy. Why is that getting all derpy? What I think is happening with the animation is it's getting to the end and then rotating back, and then it's getting to the end and rotating back. Multiplier applied to the weight of value to ease in the animation. Choose a high value for looping animations or it will be glitchy. So I think 4 will be, yeah. There. Like I don't it's a tough one to replicate. Again, I don't know what's going on with it, but you know, it is what it is. We'll just leave it like that for now. Because yeah, that's gonna do it for today, everybody. Thank you all for coming by. Everybody who chatted, everybody who interacted, I thank you very much. Please hit that like button if you enjoyed yourself today. You know, and if you learned something new, consider subscribing. Because, you know, this is what I do right now. And if you want to support the project, please consider being a patron or channel member, and supporting the project that way, or any number of my mods. And so yeah, on Saturday I've gotten and tweaked and customized and bug fixed a mod for Desynced. So we're gonna dive into that. Desynced uses a Lua backend, so it's very much anybody's familiar with like Factorio modding, Desync has a Lua backend just like Factorio does. So it's relatively straightforward, although a little different APIs. But yeah, we're gonna be using a mod, and I'm gonna do a little bit more work on it over the next couple days to get it ready, because I made a change that multiplied recipe outputs. Right, very simple. Hey, here's a sliding scale. You can multiply your recipe outputs. Now, if you multiply them by 1, there's no change. The problem is it multiplied all of the recipes by that amount. So I need to create a way to exclude certain recipes, because if I set the multiplier to 3 and I go to craft a bot, it crafts 3 bots, and I'm like, I need to I need to not do that. So I need to be able to make it so it doesn't do that. Anyway, I thank you all for coming by, and hope to see everybody back here on Saturday.